Hello everyone, welcome back to the channel. It is a beautiful sunny day here in California and even a much more gorgeous, fantastic day here in my living room. Why? You guys are looking at essentially at every model of a V-fet amplifier made by Sony in the 1970s, except maybe the Wega, so that we could keep us everything color coordinated here. Anyhow, so today we are not listening to anything. We're not repairing anything. Instead, I plan to share some historical information with you about these amps, some technical aspects, things I learned about them over the years, etc., as well as answer some questions. So, anyways, a little bit of personal history here. Is I've had these units for years in storage and never actually seen them all together. So I'm cleaning my storage right now, and I figure why don't I stage them together and share a video with the rest of the world. I share my excitement with the rest of the world, and hopefully you guys will find this some of this information valuable and entertaining. I will break the ice with one of the questions that came in, not specifically related to these amps, but specifically related to why the heck do I have a fireplace behind my stereos? And the question was a little bit on the smartass side, so I'm going to try to answer it in kind. And I was essentially asked if I'm following some fashion magazine trend and position my stereos in front of a fireplace. And so the answer to that is no, it's not fashion, but every time I turn my music on and the fireplace on at the same time, I get a warmer sound. So how is that of an answer to that smart ass question? Anyhow, there's some valid topic here, right? So my stereos are positioned in front of the fireplace because that's the optimal position for my speakers. They're firing in the length of my room, and right now I have about 40 feet of space behind me, and so, in front of them, probably more. And if I would position them in any other way, my room is not sound treated, so it would not be a benefit. So I'm trying to optimize what I have here, right? And eventually I will cover that fire. That fireplace is a nuisance. I do not like it. I do not use it. I was also asked why the heck are things on the floor, right? So I have things on the floor because I suffer over a serious storage problem, but I don't operate them on the floor. If I were operating an amp, it would be on the top shelf, so that the heat is properly dissipated. Yeah, eventually I'll cover or get rid of that fireplace together since I don't use it and it's a nuisance. But for now, until I condition my room for sound better, then it will just have to stay there and it's going to look ugly and I can't do anything about it. So that's the real reason why my stereos are positioned this way. Anyhow, let's now address a different question that was it's closer related to vintage amplifiers and maybe one of the Sonys. Came from a viewer, and it was about the restoration of the TA F7B that I did recently. Similar unit with this guy right here in mid shelf left, and not the same unit, different unit. The question came about from the viewer that asked, one of the viewers that asked me, why did I not replace the 10,000 microfarad filter capacitors with a much larger size, like 3 times the size. If you recall, I replaced the 10,000 microfarad audio capacitors in the audio amplifier with 10,000 microfarad audio capacitors for the audio amplifier. So basically like for like. And so before I answer directly, tackling directly the power supply question, I want to set the stage for a more fundamental, I would say, reality topic when it comes to working on any vintage amplifier, especially on the V-fet ones, but generically speaking for vintage amplifiers during the 1970s. That has to do with the Train of thought during those times are basically the advancements of the technology as of 1970s or early 1970s. So all these vintage amplifier designs are essentially the performance of the circuit. It's tightly correlated, highly dependent on the component characteristics. And you would say, duh, that's obvious. Well, not really. So since 1970s, progress happened, and the newer designs are less affected by minor component changes, minor component characteristics changes. In other words, if you were to replace a transistor, capacitor, etc. in the 1970s, you would have a higher chance to make the amplifier not sound the same or not be as reliable than if you did the same type of change in a newer design. In other words, the newer designs are more resilient, and engineers have learned, so they're just improved basically from that perspective. Now, this is not to say that these amplifiers don't function and they don't work well, but they work well with they're a lot more train of thought, a lot more research has to go into the replacement of components. That's the message I'm trying to say here. Now, going down to a little bit a deeper level of resolution here, more granular level on this topic. So going back to that power supply, we're talking about increasing the capacitance 300%. The viewer asked me, why don't I increase the capacitance of those filter caps to about 27 to 30,000 microfarads? And my first reaction is to ask why. And then the follow-up question was on a smartass side, I would say, or maybe a sarcastic way, but I'm going to try to answer very seriously, right? He asked me, first of all, he says, don't you know anything? Are you new at this? Don't you know that increasing the capacitors to that size would make the amp sound better? So I'll answer this way. I said, I'll say this. First of all, I don't know if I would consider myself new at this. I've done it for a few decades as a hobby. Second of all, I know I do not know anything. I've done this long enough to know that I will forever have to learn. I'll never know everything. But one thing I learned for certain is that increasing the capacitance value that much in a vintage amplifier, especially this particular unit, would severely impact both the reliability and the sound performance of the amplifier. And here's, I'm going to put a stop on that. I'm going to go back to a more generic level. What I found out over the years working on vintage amps is that even for a good technician that's just starting out with a new model, is that for about every component change we make, we're trying to improve something, we have about 10 times the chances to make something worse. So there has to be significant research in our choices of replacement components in these amplifiers. Now, going back again to the power supply question here, what I'm going to tell this viewer is that I'm not sure how you make that assessment. Maybe you've tried it on a different model, a much newer design, etc. It may work, it may not work. I can't comment to that. But generically stating that that's an improvement, it's just naive. It just shows that maybe you don't know what you don't know. I'll say this: the associated inrush current with that much of an increase of a capacitance for this particular amplifier, it will severely jeopardize the life of the primary winding of that transformer. Power switch, same, not made for that kind of current, inrush current. And then that's just the reliability of the amp, the functionality of the amp. Then we're talking about sound. Let's say that you somehow manage the amp to stay alive and power up a few times. The sound will be boomy, will sound like crap, overwhelming the rest of the frequency range. Why? As we talked about earlier, the amps are very, very finicky, very dependent on the component characteristics. And in this case, we're talking about taking the LCR tank of the power supply completely out of balance with that much increase in capacitance. And that LCR tank balance was very well calculated and implemented by the original designer in the 1970s. So it has to be maintained that way. I'm not saying you can ever make component changes, let's say increase the size or whatever on the capacitor on one of these V-fet units, but it has to be tested. Just because you read something on the internet doesn't mean it's right or wrong. What it means is that you need to cross-check and verify and do your own research. As I said, 1 to 10 chances to make a mistake, right? 10 to 1 chances to make a mistake. 10 unfavorable outcomes versus 1 favorable outcome. So you must test it. So if you have just started working on these amps, don't just assume that deliberately changing components will make a difference, a positive difference. I see this all the time, and I see this from technicians that actually do clean work, but they really don't know what they don't know. They have no clue what's going on when they start working on these amps. Deliberately changing components, increasing the capacitor size, replacing capacitors, let's say in this power, since we're talking about power supply, with the capacitors that are not audio capacitors, and thinking automatically is going to work. I'm not saying it's impossible, but I said it has to be tested. Otherwise, what you're looking at, you're replacing an audio cap with a capacitor that was made for a power amp, an audio power amp, with something like a switch mode power supply, right? Those capacitors are made differently. Audio capacitors have different foil. They're wound differently. They have different space. They have different between the foils. They have different dielectric. They're tapped differently. They have different ESR linearity at different frequencies, etc., etc. It could go on for a long time, and that's definitely a subject we must touch upon in a different video. But bottom line is, if you're replacing that capacitor that was made for an audio power supply, audio equipment linear power supply with a different type of capacitor, and think you're going to make a difference, improvement, you're wrong. You really have to test it. I'm not saying it's impossible, but the people that I've seen them make it successful, they have spent years behind. I have some modes for some of these amps. It's in the years as far as the research and goes. And it's not just my brain in there. It's not just my own personal testing, which means, and when I'm saying testing, has to be done on the bench in the listening room. I also borrow the brains of people that I'll just say outright much smarter than I am, and it still took a long time. So just thinking you're going to start shooting from the hip and you're going to hit something by, yeah, okay, here's a V-fet amp, I'm going to change this, change that, and it's going to be better because I think I read it somewhere. Come on, talk about that LCR balance in the power supply, the TA F7B, for example. Like, I see people going and saying, oh, I'm going to change this rectifying diodes. That's not a thing that I get a kick out of. With high-speed diodes, like, this is not a switch mode power supply, it's a linear mode power supply. The slowest diode out there would more than cope with the required switch speed of your mains. Doesn't matter where you are. So saying that you're increasing the switch speed of that diode is going to somehow improve the linear power supply rectification circuit, that's naive, right? It's not going to make any difference. You could say I replaced the old diode with a new diode, so now you have a new diode. That's great, fine. Furthermore, saying I'm going to replace the old noisy diode with something like a soft recovery diode, now we can have a conversation. But again, even that has to be tested. Again, I could go on and on for my rant. Bottom line is, I have one last message for the owners of vintage units, and specifically for the owners of V-fet units. I've seen horror stories for the years, and I'm not going to dive into that. You want to see some, go into my channel, see I touched upon some of them, right? Even old technicians that work for years sometimes get confused by these V-fet amps. But one thing that older technicians or technicians that have experience with these V-fet amps will tell you is that you need to know that particular amplifier, not just generally speaking. You gotta have experience with that unit. So again, message for the owners, when you're looking to service these amps for whatever reason, some for nostalgia, some of us know that they sound really good when they work. As a matter of fact, I'll make a comment here. I joke with my friends that when we hear one of these things restored, and like, we're always amazed how good they sound. We're always comments like, yeah, these things are proof that some of the best audio has already been invented, so we have different reasons to want to restore these amps. And the message is be very aware that not all technicians will understand these amps. You must make sure they have experience with this particular amp and they've repaired more than one before. Otherwise, it'd be just good target practice for that technician essentially, and your amp may or may not work properly, or it may work but it may not sound properly basically. Anyways, that's my rant. I think I said it a few times, and I'm gonna try to dive deeper into some of these topics with some real life bench testing, etc., etc. Now let's get to the meat and potatoes of this video. So let's start talking about these amps. I've arranged them here in chronological order from left to right and top to bottom, and we're going to be talking about each one of them. I will be making some stops and try to again consider adding some commentary on some of the nuances, some of the information that I found over the years. So anyways, what we have here on the left, top shelf, nothing but other than the first V-fet amplifier from any manufacturer to come to market, the TA F7B. This bad boy came to the market at the end of 1973, and there's a funny story about this because during this time the Yamaha B1 was very mature. Yamaha marketing department was essentially having the amplifier review by different magazines, and Sony essentially ate their lunch by squeezing the TA F7B to market before the B1. So good job, Sony, there. Anyhow, 1973, we're today in 2024. This is a 50-year-old amplifier. This particular unit right here, low serial number, is definitely 50 years old, and it still works. However, I would be right out of my mind to think that I could operate this unit reliably without full restoration. So let's talk about that. When restoring some of these units, let's talk about what to consider, what to look at, what topics are challenging. So this is a integrated amplifier. First of all, it's rated at 80 watts per channel, I think, into 8 ohm loads. Uses 3 complementary V-fet pairs per channel, and it has a serious preamp section. These amps run really hot. The heat sinks for that many V-fets are probably not as large as they should be, even for Class B. And so Sony introduced a set of chimneys to accelerate the rise of the heat and dissipate the heat faster. Things to watch out for restoration again are the let's start with the preamp section. Actually, there are 2 integrated circuits in this preamp section that could potentially go noisy sometimes. They're not really in ICs in the true sense of the word that we're thinking of today. They're more like analog boards encased into a ceramic or epoxy coat, and those are going noisy sometimes. So if you have one of these units that has a noisy preamp section, it's likely because of those modules, those ICs. Unfortunately, they're truly unobtainium. Can I say this? There are a few people I know, or at least one, that's been entertaining this, redoing that entire circuit. I have not. If at some point in the near future that materializes into any meaningful improvement, I'll probably do a video on it. But you know, really, if you have a noisy preamp, it's at this time, I don't know a way around it. This amp also uses 2 dual capacitors for the power supply. Again, touching upon the topic earlier, those are difficult to replace just because no one makes actually dual caps these days. No one makes audio dual caps these days, and even if you replace with something that fits the physical footprint, you will not find an audio cap that is any good. So your sound will be different than designed, almost likely, almost guaranteed, unless you put other things in balance in the circuit. Anyhow, so this thing has 2 times 10,000 microfarads capacitor, so 2 dual 10,000 microfarads capacitor for the amp section, and 2 3300 microfarads capacitor for the preamp section. So 2 dual capacitors. They will have to be replaced. Even if they still work, they are at I would say way past the life expectancy, right? Nobody thought they would last that long, so they got to be replaced. Anyhow, there's one more thing I'm going to touch on in a minute, but first let's move to 1974 and talk about the gorgeous TAN 8550, which is nothing but a separate version of the integrated 8650. 1974, this unit is introduced. It's 110 watts per channel into 8 ohms, still class B, essentially the same power stage as the 8650, and we're going to talk about a question that comes up around this topic often is like, why is this rated at 110 watts per channel, this at 80 watts per channel, if the output stage is the same? Essentially, same V-fet models, same number of them, same rail voltage, same damn output stage. The answer is actually with the Class A differential amp in the integrated amp right here in the 8650. There are a few minor differences there, and one that stands out the most is the circuit called clip protection in the 8650 that does not exist in the 8550. So now, theoretically, with some minor changes, the 8650 could be delivering 110 watts per channel. But this is one of those modes that I will not entertain. This is one of those modes where I would say just because you could doesn't mean you should. So if you're reaching out to me to ask me what to change to make this happen, you're not going to get an answer. I am discouraging you from doing so. Again, touching upon the chimneys that I mentioned earlier and the heatsinks that are not really well sized for this many outputs, keep this on a lower output value. You will extend the life of your amp. Sony has a very aggressive bias setting on both of these amps, and they're highly optimistic of the effectiveness of those chimney stacks, and maybe maybe they don't have as much benefit as they would have wanted to have. So basically what I'm saying to you, these amps run hot. Increasing and modding them up to deliver even more power for any of them is probably not advised. And if you operate them, they must be operated without anything on top. Let that heat rise as fast as possible away from the unit. Don't use them on a middle shelf like these guys right here. Anyhow, what else? What do these two units have in common also is the fact that they do not use a typical classic time delay circuit with a relay for your speaker protection circuit. So they don't have a speaker protection circuit with a relay. So there are two things to call out about that aspect. A, you may get a thump in your speakers depending on how your speakers are connected and how you're powering up your units. B, and the most important topic, is that these units do have speaker protection, but it doesn't employ a relay. It uses what is called a crowbar circuit. And in times of a situation where like you have a failure of some sort and the circuit is activated, the crowbar circuit is activated, your speakers will be safe, but the crowbar essentially shorts the outputs of the amp, and your V-fets will likely go to V-fet heaven. And so talking about modding these amps, that is one area that should be explored, and I may have some information about that in a deep dive restoration video of either of these units that may come up sometime soon. Okay, what else? The TAN 8550 uses this fantastic, gorgeous looking boom meter, digital looking boom meter. It is fast, accurate, but not digital. It is a full analog boom meter that leverages a set of meters for light transmission to be projected on this digital looking display. But again, not a digital boom meter. Very fast, very accurate, also very expensive to make. It's very unique to just a few models. It was likely a lead loss product for Sony. They used it in the TAN 8550, TAN 8250, which is the BJT version of this amp, the bipolar junction transistor output stage versus the V-fet stage and the 8550. So basically the same amplifier, except that one uses BJTs versus V-fets. It was used in the matching preamp, which we're going to get to in a minute, and the top of the consumer line of tape decks, the TC8750 in Japan and the TC8880 880 is everywhere else in the world. So just these 4 units, because it was very expensive, was not carried to their lower line or other units. So anyways, beautiful amp, gorgeous, very powerful, a statement piece again from Sony. But it requires, again, restoration and some caution on the component replacement choices, and also has areas of improvement in terms of the circuit protection circuit. Okay, we are moving into 1975. Here's the TAE 8450, the matching preamp for the TAN 8550 and TAN 8250. There are no V-fets in the TAE 8450. This preamp is here just for looks and because I had more space, so we're not going to spend any time on it. Okay, still 1975, and now we are looking at the TAN 5550, which we talked about just a little earlier. And this is the beginning and the entry of the economy line of the Sony VFET amps. I should have mentioned the top of the shelf units here in my room, and also the top of the line models for Sony were very expensive. They were about 300,000 yen in the early 1970s. And if we just do the currency conversion and the inflation factor adjustment, that's about $6,000 plus today for each of the top of this shelf units. These are very expensive amplifiers then. They're still very expensive today if they work correctly, trust me. And they should, because they sound phenomenal. If they were made today, I have a educated guess that they will cost a lot more to build this kind of exotic equipment with exotic devices, etc., output transistors, etc. So anyhow, so why did I mention this is because the economy line below, it was a third of that price. This units varied anywhere from like 90,000 yen on the left here all the way going to the right of the midsection here to the TA 5650, which we're going to get to in a minute, to about 100,000. So about a third of the price of the top of the line units, but definitely not a third of the performance. These things are just the economy line so that Sony could increase their footprint, get better market share, and they were very successful. They sold a lot of these guys. They're not Mickey Mouse units. They're really real sleepers, essentially. So we saw the TAN 5550 in my recent restoration. This thing it's rated at 60 watts per channel into 8 ohms, but it punches about 90 watts per channel. So Sony, what Sony did is essentially the 5550 is nothing but a slimmed down version of the 8550. Sony took out the expensive voltmeter, took out 2 V-fets per channel, so one less pair of V-fets per channel. This guy uses 2 complementary V-fet pairs per channel, and the side panels, when some of these have side panels, some of them don't. When they do this, just like pressed cardboard with a vinyl veneer, or like for example these were expensive plywood with like mahogany veneer. So but again, all those small changes do not amount to a third of the price difference. So really, most value for this VFET amps is in the economy line if you want to get the best bang for the buck. Also, these units have an improvement over the older brothers. As I mentioned, these guys use a crowbar circuit in the for the speaker protection, where this ones now use a relay. So this, you'll hear a relay click for all of these 3 units here when you power them up. And they have a time delay speaker circuit protection leveraging a relay. Anyhow, okay, so we're moving from 1975 to 1976, where we're looking at these 2 integrated pieces here, the TA 4650 and the TA 5650. This also happened to be the last 2 units in the what we know as the first generation Sony. Again, both punching above their rated specs. This one is rated at 35 watts per channel. It uses only 1 pair of V-fets per channel. This one rated at 65 watts per channel, using only 2 V-fet pairs per channel. What is interesting to call here is that The the Class B output stage, it uses what is called a common drain design versus the common source design, a prior amps. Also, the preamp section uses a small V-fet, which is really cool. We can't really call this a V-fet preamp, but it has a V-fet in the phono section, so I think that's pretty cool. Anyhow, again, like I mentioned, these are much cheaper in terms of price, but really punching above their weight. This one here, as well as you may not have seen, but I should probably have done it. I have the footage, I just never published it, of different restorations of 5650s. They definitely punch over 90 watts per channel. Anyhow, this kind of concludes the first generation Sonys. Their VFETs used in these units are very much the same type of VFET model. The rank is the last digit always. The first digit is just kind of indicating that that's the first generation Sony. So all of these VFETs used in the two top of the line units or the bottom ones right here will start with the digit of 5. The last digit, which varies anywhere from 3 to 8, will be the actual rank. Okay, some of things to watch out here. All of these have what's called the dead diodes. They got to be replaced. A bunch of Sony dreaded glue, which is corrosive, that needs to be taken care of. A bunch of other components need to be replaced when restoring these units, and each one of them have their own particularities. So things that have to be replaced in one unit versus the other, etc. Some of the connectors are bad. There are all sorts of service bulletins, especially on the mid section here, where Sony went back and readjusted the bias setting because they realized their heatsinks could not cope with that much heat dissipation, etc. Okay, so we're moving into 1977, and we're starting the second, what is called the second generation of V-fet amplifiers from Sony. Sony introduces different V-fets. Their first digit is different now. It's no longer 5. It could be 3 or different. And we're starting that with nothing but other than the famous TA F7B. This is one of the most known V-fet amplifiers from Sony across the world. This thing is delivering about 100 watts per channel. It uses 3 V-fet pairs per channel, but also uses 3 bipolar junction transistors per channel paired up with those V-fets. So this is not a V-fet amplifier at all. It is a hybrid. Sony figured out that if they paired up a V-fet with a BJT, they get much better linearity out of that output stage, and they did. And this amp sounds fantastic, and it is one of, as I mentioned to you, it's one of the most renowned Sony V-fet amplifiers, and revered actually, with a good set of efficient speakers. This thing sounds just delicious. Very, very nice. I have nothing but good things to say about this amp. I could talk about it for days. Design wise, this is a very drastic step away from these other guys. Okay, maybe not from this one, about from the 8550, I mean from the 5550, but still different. Very macho looking, hunky, and you can't really see the back of this amp, but if you see here, the entire amp is differently designed. It really doesn't have a top case, you know, obviously dissipates, I would say, heat a little better if it doesn't have a top case on it. But again, Sony was not the only one taking a leap in terms of like having a more outlandish design. We could see this from Victor. We know Diatone did it. Pioneer with their Class A amps did it. So it's not, Sony is not the first one, I think, in this department, but still very good looking amp. And the same year, 1977, the integrated version of the TA F7 came to market, the TA F7. It's a slightly dimmed down power output stage with only 80 watts rated power output into 8 ohms. It uses the same number of VFETs, but less BJTs per channel. So this thing uses three VFET pairs per channel, but only two BJT pairs per channel. Also has a little less filter capacitance. This uses 15,000 microfarads capacitors, 4 of them. This one uses 4 times 22,000 microfarads capacitors. Otherwise, sound signature is the same. This looks like a more docile, civilized version. I almost want to call this the Beauty and the Beast, or the fancy domesticated dog versus the rough wolf, whatever you want to call them. But anyhow, this is just a pleasure to look at, just gorgeous looking. You could see the solid carved aluminum knobs, the glass bezel for those VU meters, just beautiful. And this one right here, actually, I want to show you something. This one right here, it's got like this gunmetal color. It's called TA F7, right? It's just gunmetal, beautiful. And then we're gonna go to look at this one right here. This one, it's called TA F7B. And as you can see, the color is no longer gunmetal. It's more like champagne. I don't know if you could see it in my room, but it's really champagne color. It's like, almost says like a tint of purple in it. Just gorgeous. Both of them gorgeous. Have no complaints about either of them. Just gorgeous amps. Beautifully designed to match the top of the line from Sony, from other Japanese manufacturers on that time. Anyhow, so this kind of ends our traditional Class A, Class B, whatever type of amplifiers from Sony. And we're at the end of an era right now, 1977 still, and Sony introduces this next V-fet amplifier, the TAN88 stereo power amplifier. Very simple, still into that industrial look, just a simple blank face of aluminum. We see the matching preamp above, that is TAE88. There's no V-fets in that amp. It's here just again for its good looks and because I had extra space, but we're not going to be talking about it. We're going to focus on the amp. So this amp is, I would say, let's just state that is another true statement from Sony. Essentially, Sony built this amp to have its own type of V-fets, kind of like a la B1. So the output stage V-fets in these amps were only used in this model. They use dual die. They're twice as potent basically than the prior V-fets they use in all the other units. This thing uses, again, 3 V-fet pairs per channel, rated at 140 watts into 8 ohms. So this is the most powerful of the V-fet amps from Sony ever made. But this is not using those V-fets as your traditional amplifier devices. They're used for their quick speed, switch speed characteristics. This is a Class D amplifier. So it is not just very unique because it uses this different transistors than the prior V-fets. It is also, as far as I know, the only Class D amp to use V-fets, period, from any manufacturer. And it's also, I think, one of the first, if not the first, Class D amp from any manufacturer, just as far as technology goes. We know that Class D uses pulse width modulation as a audio signal carrier. So those V-fets are really used for their switching characteristics, for nothing else. They're not going to give you that triode mode, triode sound signature like... I'm not saying this amplifier sounds bad. It sounds very good, apparently, with electrostatic speakers. I never heard it with electrostatic speakers, and it sounds okay with my regular speakers. But the point I'm trying to make is that Sony here was at the forefront of this technologies, new emerging switch mode circuits. They're already experimenting with what it's called pulse lock power supply during this time. And then they took that technology into the amplifier stage, and so now this is essentially leveraging the V-fets, which are very, very, very capable switching devices. As a matter of fact, even the fastest MOSFETs today would have a hard time keeping up with the 1970s V-fets. Too bad they're no longer made. They're excellent technology for Class D. So yes, this kind of ends our discussion here about V-fet amplifiers and the TA N88 is essentially an end of an era and a start of a new one, all in the same unit. An end of an era because this is where the V-fet use of V-fet ends for Sony. Luckily, they had made a lot more of these V-fet models used here, so the DIY community will be forever grateful for Sony. And unlike Yamaha, they made a lot more, and they did not destroy them in the end. So you know, I know a lot of people that have built amplifiers with the remnant V-fets that were not used by Sony. Anyway, so again, end of an era because there are no more V-fets made by Sony past the TAN88, but a beginning of a new one because the Class D was just emerging during this time. And I want to take this opportunity to walk you guys through what I call the apex of the Class D technology today. Also a very interesting unit here, non-V-fet, shouldn't be part of my V-fet discussion, but I want to call it out because it's very interesting. While we have the end of the V-fet era here, the beginning of Class D, here's what we have, what I call the apex of Class D technology today, which also uses somewhat of exotic transistors. This unit here uses gallium nitride transistors. And while the V-fets, as I mentioned earlier, were top dog in terms of switching, in terms of silicon device capabilities, the gallium nitride essentially takes switch speed to a different dimension, basically outpacing anything silicon, V-fets included, or anything else by a magnitude of difference. And obviously they are made for different applications, but they are leveraged effectively by Mr. Merrill here in his Element series. This is the smallest of their amps. This unit is not essentially it's a few years old model, but it's probably the best implementation of gallium nitride. I've seen other Class D amps with gallium nitride transistors. Sorry guys if you could disagree with me, but the sound that the Merrill produces, it outpaced like the Peachtree or whatever you have out there that's trying to emulate this. Anyhow, Merrill claims no global feedback, no local feedback with this amp. So that's a bold statement. Anyhow, it sounds fantastic. So I know that Class D it's here to stay, and it's interesting to basically see its beginnings and where the apex of the technology has come to. So I thought I'd share that with you guys. This amplifier here definitely deserves its own review. I probably will do this at some point. You guys know I am a big fan of Class A, Class B, Class AB, analog, everything, but I have to give credit when it's due. So this amplifier right here, if you haven't heard Class D and you're a naysayer, you don't know what you're missing. That's all I can tell you. Anyhow, we'll dive into this later. But now, coming back to my original intent here is to basically share the visual and some details about each one of these amplifiers. And as a segue to a potential follow-up video, I want to share with you the fact that while digging through my storage, I dug out all the rest of the V-fet amplifiers ever made by any manufacturer in the 1970s. We have the Victor, the Hitachi, the Sansuis, Team Yamaha, B3. Okay, B3 over here. So we have all of them. I dug them all out. We have another fantastic amp here from Mr. Nelson Pass, but it's not yet vintage. It will be soon. Anyhow, but about the vintage amps, there was not enough room to put them all on one shelf. So I figured I had to take this video in two parts. So first was the Sony, because there are just so many of them, and then I will put the rest of the other amps on the shelf and do a follow-up session, like a part 2 of the V-fet model, the V-fet amplifiers with V-fets made in the 70s. I hope you found this information useful and your time worth. If you think I misstated anything, I made any if you think I missed anything, please correct me. If you want to add anything I missed, please do so. All jokes are welcome, including smart-ass jokes, but don't be surprised if I may answer them in kind. So all I could say, thank you for your time, and please stay tuned so we could take until we take a new deep dive into our next video. Talk to you soon. Bye.